Hello, all. This is Mr. G, and in this video we're going over reviewing proving triangles are congruent. So let's not waste any time. Let's jump right in. So for the first four, they give us this congruent statement. It says GDIR is congruent to AOEU, and we have to fill in the blanks. So let's take a look. Number one, segment IR would be congruent to, well, IR is right here, so that would be segment EU. All right. Number two, angle A is right here, so that would be angle G. Angle G. UA, so these are kind of split up. We've got a U and an A, so then that would be R and G, so segment RG. And last but not least, number four, angle D, that's the second one, so that would match up with angle O. And then we can double check my answers right here from the answer key. Let's see, EU, angle G, RG, and angle O. So far, so good. Let's keep rolling. Number five, sort of similar to the first four, it says triangle SHR is congruent to triangle WQF. So they're giving us a congruent statement, and it says name two congruent sides and two congruent angles. Now there's a lot of different answers here. That's why it says answers may vary. But let me see. What would two be? Congruent side, that could be segment HR, being congruent to segment QF. That would be two congruent sides. And then two congruent angles, I don't know, angle S being congruent to angle W, since they're in the same spot. What answers do I have under here? So segment SH and WQ, that would work as well, or angle R and angle F. There's lots of different answers for that one. Okay? All right, now we get to the real meat of what we're doing here. So are the two triangles congruent? Why or why not? So here we need to know our patterns, which congruence patterns work and which ones don't. So let's jump right in. Number six, I like to mark the pairs of congruent parts. So let's see, I've got a pair of congruent angles, so we'll put an A there for angles. I see another pair of congruent angles, K and G, and then we see a pair of congruent sides, segment KR and segment AG. And then we just have to see what pattern we have. So we have two angles and a side that's not in between them. So then this one would be angle, angle, side. And then this one would also be angle, angle, side. Two angles with the side that's not in between them. So the answer is yes by angle, angle, side, because angle, angle, side is one of the patterns that works. And that's what we got in the answer key as well. Okay, let's take a look at number seven. Same directions. Are the two triangles congruent? Why or why not? And same thing. I'm just going to mark the pairs that I see that are congruent. Got a side marking there and a side marking here. Another side marking there and there. And no more sides, but we've got a pair of congruent angles as well. I don't know why my mouse keeps showing up like that. That's kind of weird, but whatever. Where was I? Okay, now we just have to look. So in this triangle, I see two sides, angle in between them. That side, angle, side. Same thing here. Two sides with an angle in between them. So that's side, angle, side. So the answer is yes. By side, angle, side. Hopefully that's what's under here. Yes, it is. So far, so good. Number eight. Same directions. Let's jump right in. No side markings here, at least none given to us. I see a pair of angles that match. I see another pair of angles that match. And that's two pieces of information. That's not enough. We always need three. So this is either, I'm on the wrong one. There we go. So either this is not enough information or there's some markings that we can add in here. And I see an X. I see an X for vertical angle. So I can add in these angle markings. So I've got another pair of angles. So then this is angle, angle, angle. But AAA does not work. So the answer is no because of angle, angle, angle. That's one of the patterns that does not work. At least for congruency. It does prove that they're similar, but we're not talking about similar triangles this chapter. This chapter is all about congruent triangles. All right, away we go. Number nine, same direction, so we're going to approach it the same way. Let's mark what's congruent. I see a pair of congruent sides. Same number of notches there. Another pair of congruent sides. And a pair of congruent angles. So here we've got three pairs. It's just a matter of looking at what we have. So we still have two sides, but now the angle is not in between them. So that would be side, side, angle. And same thing here. Two sides with an angle not in between them. So we would say side, side, angle. And this does not prove congruency. So no by side, side, angle. All right. Number 10. Start the same way. I see a pair of congruent sides, same number of side markings, same number of angle markings for those two, and here as well. So here they already give us all three, so now it's just a matter of picking the pattern. Here, let's see, it's two angles with a side in between, two angles with a side in between, so that's angle, side, angle, and that is one of the patterns that works. So it's yes by angle, side, angle. Okay, so far so good. Number 11. Let's take a look here. Pair of sides and another pair of sides, and that's it. So again, we have two, but we need three. And we see an X for vertical angles, so I can add in those congruent angles and mark them as a pair of congruent angles. Now we just have to figure out, okay, what pattern are we looking at? So in this first triangle, I see two sides with an angle in between, that side angle side, and in this triangle, I see two sides but the angle is not in between the two sides. Like here, I've got this side, and the angle's not in between them. So that one would be side, side, angle. So even though side, angle, side works for proving triangles are congruent, this one's going to be no because the patterns are different. I don't feel like writing all that, so I'll just show you the answer. The patterns need to match. So we've got like side angle, side, and side angle, different patterns, so the triangles are not going to be, or we can't prove that the triangles are congruent. All right, let's scroll down. I think we're on to a new section. Yeah, so now now the directions are changing. So it says, what additional information is required to know that the triangles are congruent by, and number 12, they want us to use angle, side, angle. Now I'm going to approach these pretty much the same way as the last section of questions. I'm going to start by looking at what they give us. So I see a pair of angles right there, and that's it. Which sort of makes sense because they're asking what additional information do we need. So whenever we see an additional information problem, we're going to know, okay, we could not prove these triangles are congruent based on what we see. There's going to have to be something extra that we'd have to add in, something that's missing. But we shouldn't be missing two pairs. We should only ever have to add one thing in. So my question is, what do we see? Are there markings we're allowed to add in? And we see another X for vertical angles. So we can mark that angle and that angle with another pair of angles. All right, so we've got two angles, so we're missing a side. We're missing a pair of sides. So then the question is, in this triangle, where would the side need to be to make an angle, side, angle? Two angles with the side in between it. And we would need it marked right there. So we would need DV, so segment DV. And in this triangle, the side that's in between those two angles is right here. That's segment VB. So we would say segment DV and segment VB would need to be congruent. Would need to be congruent. And hopefully that's what I have under here. Oh, that didn't work well at all. Let's scroll that down a little bit. Let's see, segment DV. Oh, I said VB, but this one says BV, but that's the same thing. Same thing. All right, so that one's done. Let's move on to number 13. What additional information? Same directions. Let's jump right in. So here we're using HL. So we need to have 90 degrees here. And we see 90 degrees. I see 90 degrees right there, which means automatically this other angle is also 90 because they make a linear pair. There's a semicircle right here. So they both have to be 90. We remember that from earlier chapters. And that's it. So now we have to look for other markings that we're allowed to put in there. And I see a side marking we're allowed to put in. This side marking right here, because the two triangles are sharing that side. So by the reflexive property, that segment QK is congruent to itself in both triangles. So tell you what, we can mark that as a side in both triangles. Oh, and let's mark the angle as well for the 90 degrees. Okay, so we're looking for HL. So now let's focus on one triangle at a time. In this triangle, we've got 90 degrees, which is good, and we have a leg, which is good. So we're missing the hypotenuse. We're missing the hypotenuse, and the hypotenuse in that triangle is right here. If you ever have trouble identifying the hypotenuse, just imagine that the right angle was like an arrow pointing at the hypotenuse. I know that's kind of stupid, but that always helps me. So what segment was that? Let me undo that. So that was segment MK. Let me try and write this down here so it's not over the answer. And what would it be in the other one? In this triangle, the hypotenuse, again, sort of imagine this is an arrow pointing at the hypotenuse, it would be RK. So I can undo that now that we see it. So we would need this to be marked. So segment MK and segment RK would need to be congruent. Would need to be congruent. And hopefully that's what I have under here. Let's take a look. MK and RK, very good. We need to be congruent. All right. Take a look at number 14. Same directions. Side, angle side this time. All right, let's take a look. Oh, we've got 90 degrees again, so we can add in 90. I think this is actually the same diagram. They just changed the rule they want us to use. So let's mark those two angles. And again, we see the reflexive property, two triangles sharing a side. So we can mark that as a side in both triangles. And then side, angle, side. So we've got a pair of sides. We have a pair of angles, but we're missing this extra, this second pair of sides. So that's the additional information we need. So in this triangle, that one right there, to make it side, angle, side, two sides sort of surrounding that angle, making it an included angle, we would need that segment. So it would have to be segment MQ. And in this triangle, to make it side, angle, side, to make it two sides with an included angle, the angle in between the two sides, we would need it right there. This one away. So it's segment MQ. And what was the other one? Segment QR. Segment QR would need to be congruent. Would need to be congruent. I know it's annoying writing out the whole sentence, but it's absolutely critical to do that. Would need to be congruent. Started talking, forgot where I was. And is that the answer? MQ, segment RQ. And again, we've got RQ and QR, but it means the same thing. It means the exact same thing, so don't worry about that. If you have the letters backwards, it's totally cool. All right, number 15, same directions. This time we're using angle side. So let's take a look at what we have. I've got a pair of angles. Oh, and this diagram looks familiar as well. I think this is the same picture, but with a different pattern they're telling us to look for. Again, we see the X for vertical angles, so we can add them in and put an A to signify that they're a pair of angles. And now we want angle side. And there's actually a lot of different possibilities we could have for this. So let's just take it one at a time. So in this triangle, for angle side, we need a side that's not in between the angles. So we actually have a choice here. I guess I'll use this one. Oh, I don't want to mark that because we don't know they're congruent. We would just need it to be congruent. So we would need segment CB to be, so segment CB and segment, let's see. In this one up here, CB looks like it would match up with DT. So segment CB and segment DT would need to be congruent. Would need to be congruent. And let's see if that's what I have under here. DT and CB. Okay, I just put them in the opposite order, but that's all good. Or VT, segment VT and segment VC would also work. With angle side, we've got more options than with angle side angle, because for angle side angle, there's only one side that's in between the angles. But for angle side, the side is not included between the angles. So we've got more options there. It could be either, CB, we do this in different color, could be CB for this triangle, or it could be CV. Both of them are non-included sides. They're not in between the two angles. All right. Number 16. Same directions. This time we're looking for side. So let's take a look. I see a pair of sides. I see another pair of sides. So obviously we're missing a pair of sides, which I guess was kind of obvious because if it's side, all the sides need to be marked. So we're missing HW and segment GK. So I don't want to say this. Segment WH would need to be congruent. To be congruent, and I'll cheat and use the symbol like I've been doing. Would need to be congruent to, what's the last one? Segment GJ. There we go. And is that what I have under here? WH and GJ would need to be congruent. Excellent. Very good, very good. Still the same directions. I'm getting kind of tired of these directions. All right. This time we're looking for HL. Oh, and this one is actually one of the trickier ones on this review. So let's take our time and make sure I'm going through this carefully and showing my thought process and not screwing this up. So they actually give us a lot of information. They give us two sides, a pair of sides right there and a pair of sides right there. Because remember, HL is sort of like the special case of side angle, where the angle is 90 degrees. So when we're looking for HL, we're looking for side angle and the angle being 90 degrees. So we got two pairs of sides, and then we actually have a pair of vertical angles because we have an X. So we can put that right in there, pair of vertical angles. So we actually do have side angle in both of these triangles. Side angle. So at first glance, it might be like, well, nothing's missing. We have side angle, but that's incorrect because side angle does not work. For this to be HL, we would need the angles to be 90 degrees. So you might be tempted to just say angle T, but let me do this in a different color. 1, 2, 3, 4. All of those angles could be called angle T. So we're going to have to be more specific when we're naming our two vertical angles. So I'm going to say angle LTW using 3 points to sort of trace the angle to be more specific about which angle we're talking about. So angle LTW and angle, what's the other one? DTA. And they don't need to be congruent. They are congruent because they're vertical angles. We would need them to be right angles. So those two angles, angle LTW and angle DTA, would need to be right angles. Would need to be right angles. Right, and I'll just use the angle symbol there. Hopefully that's what I have under here for the answer key. LTW, DTA would need to be right angles. Very good, very good. Oh my gosh, still more additional information problems. I'm sick of these directions. Okay, looking for angle, side, angle. Let's take a look. They don't give us a lot here. I see a pair of angles, and that's it. I do see something we're allowed to add in, though. Those two triangles are sharing a side, so by the reflexive property, this segment UD is a congruent side in both triangles. So we're missing an angle. We're missing a pair of angles. We want it to be angle, side, angle. So in this triangle, the missing angle to have and included the side in between the two angles, we would need this angle to be marked. And in the other triangle, let's get rid of that. In the other triangle, this triangle right here, we would need this angle. That would make it angle, angle, side. So we can move that out of the way. And then we can just write our answer. So angle, again, we cannot say angle D because both of them could be called angle D. So we'd have to say angle SDU and angle, what's the other one? TD, that's a U up there? Yeah, TDU. TDU would need to be congruent. Would need to be congruent. And let's double check the answer key, or double check ourselves rather with the answer key. Okay, I named it in the opposite way. So UDS and SDU, that's the same thing, just backwards. And UDT and TDU, I did the same thing. They're backwards, but it's the same thing. They're talking about the same angle. Two different names for the same angle. So that was good. Hopefully we're on to some new directions by now. Okay, yeah, finally some new directions. These are no longer additional information problems. These are problems where we have to prove. All right. Now, whenever it says prove, I can't speak for all math teachers, but when I say prove something, it is able to be proved. So if I say prove something, it's never going to be like not enough information, or it's not going to be angle, 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 or it's not going to be side, side, angle. It's going to be a pattern that actually works. So let's jump right in. This diagram, to me, looks sort of empty, like there's no markings. But fortunately, they give us a given statement. They give us some markings that we're allowed to put in. So I'm going to put them in black just to show that they're part of the directions, essentially. So segment AE is congruent to segment UE. We can mark that. And segment AO, we'll put 2 there, is congruent to segment UO. And that's all they give us. So let's start our proof. So I draw the line for the 2-column proof. Let's move this over slightly. So let's see. First, I see a side there. So segment AE is congruent to segment EU. I guess I'll put UE just to match what we have there in the directions. Segment UE. Now, in case a student is watching this and thinking, well, wait a minute, how do I get started with these? Don't overthink it. Just look for what's given. Look for parts of the diagram that have the same number of markings. Oh, I see 1 marking there, and I see 1 marking there. That means they match. That means they're congruent. So we name them. So those 2 segments are congruent, and the reason is because it's given to us. It's my favorite reason in the world. No thought required. They just gave it to us, and we're ready to move on. What else do I see? I see another pair of side markings right there. So we can say, what is that? Segment AO. Let me draw a line just to separate this. Segment AO is congruent to segment UO. I guess we could have stolen it right from the directions right there. UO. And again, it's given. They just gave those markings to us in the directions. And now we're all out of markings. We're all out of given. And that's no good because 2 is not enough. We always need 3 pairs of congruent parts to prove triangles are congruent. Unless there's some weird exception I can't think of. But in this chapter, at least, we always need 3. So let's see. There's got to be something we can add in. And I see it. The triangles are sharing a side. So we can add that in both triangles. So we can say segment EO is congruent to segment EO by the reflexive property. Anytime we're saying something is congruent to itself, that's the reflexive property. Reflexive property. So that's something you really want to be on the lookout for in this chapter. If two triangles are sharing a side, you got to think, oh, that's a good time to use the reflexive property. Just like whenever we see an X and we think vertical angles, same thing. All right, so we've got 1, 2, 3 things marked. So that means we're ready to prove the triangles are congruent. And I'm going to steal this right from the directions. So in the directions, it says those two triangles, those are the two I'm going to write. So I'm going to say triangle AOE is congruent to, little lag there, is congruent to triangle, what was the other one? UOE. Stealing it right from the directions. Now it's time for the most important part, where we have to pick what pattern are we looking at. And here, this one's actually hopefully not too difficult. It's just side, side, side. We have 3 pairs of congruent sides, so that proves the triangles are congruent, and we are finished with this problem. Moving on. Looks like we've got 1, 2, 3 more problems to go in this review video. So it's another proof, and we have to prove that triangle WDG is congruent to triangle FKG. There's no given statement here, so the markings are already there waiting for us. So let's not waste any time. Let's go in there and find them. So I'm going to draw my line right there to separate the two columns for the 2-column proof. What do we see first? I see a pair of sides right there. So we can say that segment WG is congruent to segment GF. And that's given. The markings were there just waiting for us. Any other markings? I see another pair of sides right here. Segment DG is congruent to segment GK, or I guess I could say KG. Doesn't really make a difference. And again, that's given to us. And we're all out of given markings. So now it's up to us to find something that we're allowed to add in. And hopefully, as soon as you saw this problem, you saw that X right there for the vertical angles. So we can add those markings in. So that angle is congruent to that angle. I'll put an A there just to emphasize that it's an angle to us. We cannot just say angle G because they're both angle G. So let's see. I'm going to call the first one angle WGD is congruent to angle FGK. Sounds like a bad radio station. And that's because of vertical angles. We know they're congruent because they were vertical angles. All right, we've got our 3 pairs. Now it's time to figure out what pattern we have. So in this triangle, let's see, we've got 2 sides with an angle in between them. So that's side angle sine. So, go away. There we go. So side angle side. Oh, I forgot to put the triangles. Let me steal that from the directions real quick. WDG, is that what it was? I'm already forgetting. WDG and FKG, congruent to FKG. I'm just going to double check that one more time so I'm not doing this incorrectly. FKG, WDG, very good, and we're finished. Okay, so far so good. 2 more to go. I think this one might be the most difficult one. Like in my experience, if students are going to have trouble with one of the proofs on this review, it's probably going to be this one. So I'm really going to take my time and try and explain this the best I can. Let's see what we have. It's saying given segment YV is a bisector of segment UW, and we have to prove that these 2 triangles are congruent. So let's just start with what we see. There's our column for the 2-column proof. What markings do we see here? Well, I see an angle marking there on angle Y and a matching angle marking on angle X. So that's given to us. So we'll say angle Y is congruent to angle X because it's given. Favorite reason in the world. All right. And those are the only congruence markings they're giving us. They're also giving us 2 arrows, but remember, arrows do not mean they're congruent. It means that they're parallel. So we probably need to use those parallel lines at one point. Let's go back to this given statement before I forget about it. Because essentially we only have 1 pair right there, and we know we always need 3. So we've got to find 2 markings that we can add in here, or 2 pairs, I should say. So let's start with the bisector. Now, hopefully we know the word bisector means cut in half, cut into 2 equal parts. And it says that segment YV is a bisector. So that means segment YV is doing the bisecting. That's the segment that's cutting something in half. And what is it cutting in half? Well, it's cutting segment UW in half. So if this segment UW is being cut perfectly in half, perfectly into two congruent parts, that tells us that this segment, that half, is congruent to that half. So we can add those markings in because the directions told us that YV, segment YV, was a bisector. So we can say segment UV is congruent to segment WV because of the definition of bisector. I'll put definition of bisector. That might not be good enough for like a college professor, but at our level, that's totally good. That's good enough. That's rigorous enough. Okay, we've got two pairs, 1 and 2. We just need one more because we know we always need 3 pairs of congruent parts. So let's see. We've used up all of the given, and I don't see any more markings in. So now it's time to see if we can use these parallel lines. And this is what trips students up in my experience. Whenever we have parallel lines, we should look for a transversal. And the transversal here is actually UW because that's a line that's intersecting both of the parallel lines. And when you heard transversal, hopefully you thought, oh, transversal. So we can look for like alternate interior angles, or we can look for same side interior angles, or we can look for corresponding angles. I don't see a Z anywhere, at least one that's going to help us. I mean, technically we've got a Z right there connecting this angle and this angle. But the only trouble with that is that this angle right here isn't inside one of the triangles. So even though we have a Z, we don't want to use that. Let's undo that. So the Z's are out. And same side interior angles, I don't want to use because they're not congruent. They're supplementary. So the last one we have, the last pair, are corresponding angles. Now remember, corresponding angles, that's when like we take an X and drag it along the transversal and everything matches up perfectly. So let's see if we can do that. So in this parallel line, like that's the only angle I see between the parallel line and that transversal UW. And if I drag it over from one parallel line to the next parallel line, hopefully you see that this angle matches up perfectly with that angle. So we can add them in because they're in the same position, meaning they're corresponding. And if they're corresponding, that means they're congruent. So that's our third pair. I can say angle U is congruent to angle, and I can't say V because we've got 1, 2, 3 different angles. That could be called angle V. So this one would be XVW. So I'm going to call it angle XVW. Come on, smart boy. XVW. I'm going to check that name one more time to make sure I'm not making a small mistake. XVW looks good. All right. Oh, I need to slide this down slightly. There we go. And that was because of corresponding angles. They were in the same position, going from one parallel line to the other using a transversal. Corresponding angles. Okay. Where were we? Oh, I forgot to mark these pairs of angles and those pairs of sides. I guess I could have just put one marking there, right? Whatever, it doesn't really matter. What pattern do we see? I see angle, angle, side. 2 angles with a side that's not in between them, and I see the same thing in both triangles. Angle, angle, side it is. So we can say, let's deal it from the directions. Triangle YUV is congruent to triangle, what did they name the other one? YUV and XVW. XVW, I'm going to check those names one more time, making sure I'm not making a small mistake here. YUV and XVW looks good. And that was because, what was the pattern? Angle, angle, side? Yeah, 2 angles with a non-included side. So it's angle, angle, side, and there we go. I'm going to double check that pattern one more time. I always hate when I make a mistake at the very end of the video and have to go back and edit. Angle, angle, side, and both. Yep, looks good to me. Okay, last but not least, final. Okay, we got to prove the 2 triangles are congruent. Let's not waste any more time. Let's jump right in. First statement, the only congruent markings I see are those 2 marking the congruent sides. So we've got this side, which is segment AU, and that's congruent to this side, which is segment IO. And that's because it's given. Now, there's actually a few different ways to do this problem. We can either use our parallel lines, or we can use our vertical angles. I'm going to use the parallel lines, but you don't have to do it this way. Using the parallel lines, I'm going to, again, look for any transversal angle pairs. So I'm looking for alternate interior angles. Same side interior angles, really not that helpful in this chapter, or at least this type of problem, because we want things that are congruent. And same side interior angles are supplementary. So really looking for alternate interior angles or corresponding angles. So alternate interior angles, we're looking for a Z, and I see a Z right there between this angle and that angle. So angle A and angle O. So let's mark it that way. So we can say angle A is congruent to angle O. Angle O because of alternate interior angles. Alternate interior angles. Angles. And tell you what, I see another pair of alternate interior angles right here. Angle U and angle I. So I'm going to sort of cheat a little bit and put them on the same line. So angle O is congruent to, angle A is congruent to angle O, and angle U is congruent to angle I. And both of those are going to be for the alternate interior angles. That one reason for both of those pairs of angles. And we've got three. We've got 1, 2, 3 pairs. That means it's time to prove the triangles are congruent. It's time for that last step of the proof. So I'm going to steal it right from the directions. I'm going to draw a line here just to sort of separate the proof and the diagram. So angle AUE is congruent to triangle, needs some more space, OIE. And why is that? What pattern do we see? Oh, I forgot to mark my angles. Angle, 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 angle. You don't need to do that. It just helps me sort of model my thought process. So in this one, I see 2 angles with a side in between them. Do I see the same thing here? 2 angles with a side in between them. That's angle, side, angle, and we are finished. All right. Hopefully that was helpful. If you have any questions, by all means, let me know. Good luck studying for the quiz. I'll see you all tomorrow.